Chapter 24 Notes, Properties of Light. There are different models we can use for light to help us explain different phenomena that it does. We've been using the particle model of light that says light acts like a particle, travels in a straight line, and we use that for our ray model diagrams. This week we're going to be looking at how light acts like a wave. Properties of waves we've studied in the past are reflection, refraction, interference, and diffraction. Since light does all four of these things, light acts like a wave. Pause and copy. If we apply the particle model to Young's double slit experiment, we have our light rays coming in, and we would expect two light rays to be coming through the slits, and you would see two bright spots on the screen. Instead, we see a series of bright spots, which means we're going to use the wave model of lights to explain what's going on. Pause and copy. To do this, we're also going to look at Huygens' principle. Huygens says that light is actually a series of wave fronts coming from a particular source. So each one of these lines represents like a crest of a wave, and every space represents a trough of the wave, and we have these lines coming out. This is typically the drawing that we see in a textbook for Huygens' principle, where the red line is the ray model of light, and the blue line would be Huygens' wave model of light. We use this model to help explain refraction in general and Young's double slit experiment. Basically, Huygens saying every point on a wavefront acts like a new wave source. So here we're going to start with our wave source. We have a wave front coming out of that, and that front is divided up into an infinite number of point sources. And each one of those point sources generates its own waves, and eventually those waves will add together to make the next wavefront. And then that wavefront is also made of an infinite number of points, which can generate their own wavefronts, and they all add together to make one large wavefront. The farther the wavefronts get from the source, the more parallel the light rays become, and that's how they add together, and this is also how we get the parallel light rays for Young's double slit experiment. Pause and copy. Huygens also can explain refraction using his wavefronts. As the waves are hitting the water, of course, they're slowing down. And we said each line on the wavefront represents a crest of a wave. So the distance from crest to crest is a wavelength, and that can be measured by the speed of the wave multiplied by the time, or the inverse of the frequency. As the wave enters the water, the frequency or time stays the same, but the speed is decreasing. Therefore, the distance between them is decreasing because v times t is the distance. Back to Young's double slit experiment. Instead of using the particle model, we will use the wave model. We will have these wave fronts coming in, and as each wave front hits one of the slits, the thin slits act like point sources of light. So each point source will have the wave fronts coming out in a circular pattern. So if we have two slits, when the wave fronts hit them, they will come out and form an interference pattern on the screen. You can see from the drawing where the crest and the crest add together, we get a bright spot. Where crest and trough add together, we get a dark spot, bright spot, dark spot. This will explain the spotted pattern on the screen. We also need this model to explain how the 2 point sources work, because this is the same wavefront that's hitting these two slits. These two sources are in exact phase with each other. And this is the biggest problem in trying to get Young's experiment to work properly. If you have two separate sources, the lights will not be in phase with each other, and you will not get this pattern. The light had to be exactly in phase with each other, and the only way to do that is to send a parallel wavefront hitting both splits at the same time. So our interference pattern, the bright spots are called bright fringes, and the dark spots are called dark fringes. They're also called maximum and minimums. They're also called antinodes and nodes, and we have to understand what's going on is constructive interference and destructive interference. Pause and copy. this is how we draw the double slit pattern. We show the bright spots with the lines, and where we did not draw a line, those would be the dark spots. Notice that they are evenly spaced. Pause and copy.